Now let's take a look at vertical stretch or shrink. When you have a vertical stretch or shrink, you have a constant c out in front of your function. To multiply the entire equation by c means that I'm going to multiply the y coordinates by c. The x coordinates will stay the same. So taking a look at our function here in number 7, I want to take each of my corners and multiply them by c. So let's start off with the first point here, back at negative 6, 0. If I multiply let's find y equals 2 times f of x first. If I multiply the y coordinate of 0 by 2, it stays 0. Then my next little corner here is at negative 4, 3. So if I multiply the 3 by 2, that's going to be at negative 4, 6. Notice that it's twice as tall. Then if I take a look at, for example, negative 2, 0, it's going to stay at 0 because 0 times 2 is 0. Then taking a look down at my bottom here, at 0, negative 3, if I multiply the negative 3 by 2, that's going to be at 0, negative 6. Then I have a point at 2, 2, which will become 2, 4. And I'm going to end here on the x-axis at 4, 0, because again, 2 times 0 is 0. If I wanted to find y equals 1/2 f of x, it's going to be half as tall. So again, all of my x-intercepts are going to stay, because 1/2 times 0 is still 0. Then I'm going to go to my first corner here at negative 4, 3. Half of 3 is 1.5. Then I can go to my 0, negative 3. Again, half of 3 is 1.5, so negative 1.5. And then I've got the point 2, 2, which will become 2, 1. And I can end again at 4, 0. Vertical stretch and shrinks are easy because you just multiply the y coordinate by that value of c. Horizontal stretch or shrinks are the weird ones. If you have a c inside with your x, then you're going to multiply the x's by 1 over c. This is because it's going to happen twice as fast, or 3 times as fast, or half as fast in the original period. So looking at number 8, my original graph ends at 6, 0. If I want to find f of 2x, that means it's going to happen twice as fast. So I can fit 2 of these graphs within the original. So if it's happening twice as fast, and I want to fit 2 of them within the original, then I have to multiply the x's by 1 over 2. So let's start off at 0, 0. Anything times 0 is still 0, that's going to stay. So then I had a point here at 1.5, 4. So half of 1.5 would be 3/4, 4. Then I had a corner here at 3, 0. So now I'm going to be at 1.5, 0. Then I was down here at 4.5, negative 5. So now I'm going to be at 2.25, negative 5. I ended at 6, 0, so now I'm going to end at 3, 0. So notice that I could fit a whole nother one of these in the original period. If I take a look at f of 1/2 x, now I can only fit half of the x's within the original period. So that means I have to multiply the x's by 1 over 1/2, so I'm multiplying the x coordinates by 2. So I'm going to start here at 0, 0. Then again, my top was here at 1.5, 4. So now I'm going to be at 3, 4. My middle point was at 3, 0. So now it's going to be out at 6, 0. Then my third point was at 4.5, negative 5. So that's going to now be at 9, negative 5. And then if I originally was at 6, 0 ending, now I'm at 12, 0. We can just approximate those ones. So notice I can only fit half of the graph within the original. Looking at even and odd functions. To be even is symmetric with the y-axis, which means that if the point 2, 4 is on the graph, so is the point negative 2, 4. To check to see if a function is symmetric, when you replace x with negative x, you get the same as the original equation. So let's check and see if, for example, number 10 here is an even function. So when I plug in a negative x, I get 2 times negative x minus negative x squared. And so f of negative x is going to be a negative 2x and then minus x squared. Notice that it is not the same as the original, so it's not even. Let's check number 11. F of negative x, 7 minus a negative x to the 4th, is going to give me a 7 minus x to the 4th. So it checks out. It is an even function. It's the same as the original. To check to see if it's an odd function means that you're symmetric with respect to the origin. So if the point 2, 8 is on the graph, so is the point negative 2, negative 8, which means that points in the first and third quadrant match up and points in the second and fourth quadrant match up. And we'll take a look at this graphically in a minute. So if the point 2, 2 is on the graph, so is the point if the point 2, 8 is on the graph, so is the point negative 2, negative 8. When you plug negative x in, you want to get a negative f of x. So let's look at number 9 and see if it is odd. So when I plug a negative x in, I'm going to have a negative x cubed minus negative x. And so notice I get the opposite signs. I get negative f of x. So it checks out, it's odd. Now number 10 was not even. Let's check to see if it's odd. It's not odd either because I should have negative 2x plus x squared. So this would be neither. If you're just looking at equations, the easy way to tell is if all my exponents are even, it's even. If all of my exponents are odd, it's odd. If it's a combination of even and odd exponents, it's neither. So now let's take a look at this graphically. If I take a look at my first graph, y equals x to the 4th plus x squared minus 3, notice that it's exactly the same on the left-hand side and the right-hand side of the y-axis. It's symmetric with the y-axis. Notice that my second graph, my blue graph, is odd. Every point that is in the third quadrant has a matching point in the first quadrant. So odd is matching in the first and third quadrant or second and fourth. Even is symmetric with the y-axis.